Hello everyone, I am Professor Mani, Assistant Professor, Department of Electronics and Communication Engineering, Maratha Mandal Engineering College, Belagavi. So today, let us have a discussion on DC power supplies. So I'll show a few components here. So basically you can see that I'm having two dry shells. These particular devices, they are acting as DC sources of energy. This particular source of energy is very important because in all our gadgets like televisions, laptops and remotes and everywhere in our daily day-to-day life, DC source of energy is very important, and that can be achieved by these kind of devices, which we also call it as shells and as well as batteries. But the basic problem with these kind of sources of energy, so what you see here is this is not long lasting. So you can see that this is the energy that is being stored has to be replaced every time. So it's not a better way for signal processing, etc. So therefore the convenient and the economical method for getting a DC source of energy is conversion from AC to DC, because AC is available every time with us. So therefore we have to design a circuit in such a way that AC power can be converted into DC power. So you can see here dry cells or batteries or the basic form of DC source, and the conventional way conversion, the later on that is called as rectification. The process of converting AC signal into DC signal is called as rectification, right? So therefore when I say it as a DC source, what do we expect from a DC source? A DC source should provide constant energy at all the times. So let us see what is basically a DC power supply. So in a DC power supply, you can see that a DC power supply consists of step down transformer, and you have a rectifier, a smoothing filter and a voltage regulator. So all these components form together a DC power supply, and the basic part that you see here is rectifier, which is required for conversion of AC to DC. So in this session we will discuss on rectifiers. So you can see here I am applying an AC voltage through a help of step down transformer. I am reducing the voltage here. So once I apply the signal to a rectifier, you can see that the output what you get from a rectifier is not a pure DC, it's called as pulsating DC. Later on I use a filter here to remove the ripple components, and later on we have a regulator here. So you can see a transformer here and a capacitor, a diode, right? And you also have a transistor, and there is a Zener diode. All these components, they form together as a basic block diagram of your regulated power supply, right? So the halfway rectification process. So this is where you can see the circuit diagram of an halfway rectifier, which consists of a transformer, diode, and as well as you have a load. And we also have the operation of this particular rectifier during positive half cycle. You can see that the diode is forward biased, and during negative half cycle the diode is reverse biased, and you see that the output voltage is available only during positive half cycles, right? So therefore a halfway rectifier will give you output voltage only during positive half cycles. That's all for today. So the next learning we will see in the next sessions. Thank you everyone.